Next, I'm going to show you how to use dynamic lock. So I'm going to place a new tag. This tag is different from my earlier video because I just ruined the tag. I was playing with the locks and it's got locked. Okay, activate, and this is a brand new tag, and as you can see here, the dynamic locks is here in page number 40. So this tag also has got a static locks, which we know. Now the reason why this is called the dynamic locks whereas the lock here is called static locks, the reason is the position of the static locks, that is page number 2 and by 2 and 3, this is fixed for various types of NTAGs even though the size are different, whereas the dynamic locks, because of this, the position of the dynamic locks depends on the total the memory. So in this 203, the dynamic lock is present in page 40. Maybe if you look at 213 or 215, you'll see that dynamic locks are in a different page number. So it is for that reason these lock bytes are called dynamic locks. And also, to put in simple words, so this tag has got more memory, so there must be somewhere to or some mechanism to lock the pages. So that's what we do in using the dynamic locks. So in case of 203, we have seen this in the documentation. The first 2 bytes are for dynamic locks and the remaining 2 bytes are not used. So I have encoded this into a nice a section here called dynamic lock, and the documentation says the first byte controls or locks what you see on the left side, and the second byte is what you see on the right side. So here each bit locks not just one pages but more than one. In this case it's going to lock 4 pages each. So I'm going to write something and just try to get some lorem ipsum. So I'm just copy paste, that is write something and lock as well. So at least we'll be learning some write operations here. I'm going to paste some lorem ipsum and I'm going to copy everything from here and transfer it to page number 4. So I'm going to use this section, page number 4, block 0, save. So this is just a tiny operation moving the string from this text area to this grid. We still haven't written anything to the tag, and I'm going to clear the screen and let us try to transfer everything from page number 4 to page 39 and say write. Now the write is successful. So how do we know it's successful? It's not just because of my message. So you can see that I've sent so many the write commands. There's nothing special here because we have seen these write commands in MeFair ultralight tag also. With just every write command carries a one page full of data, that is 4 bytes, and the return value for all this is 90 followed by 04 followed by 0A. 0A is the positive acknowledge, and followed by these things are the control bytes. Okay, I'm going to take out and restart again just to make sure the write is alright. So you can see that the lorem ipsum characters are here. Let us try to lock. I'm going to lock the page number. I'm going to use, if I tick this bit, and I'll be locking page number 36 to 39. So let us do that. A write. So my software immediately shows they are locked. However, I'm going to show you something in the documentation. So if you look at this documentation paragraph here, it says the configuration returned in the log bytes is active only upon the next REQA or I think it's a WPA command. Okay, so what it means, okay, so the locking will be effective only after, okay, you again put the tag back into the field. So I'm going to, let us try to do that. We know it's locked, the software says it's locked, and I'm going to use this trick I've got in my software. Now this is where this is the section we used to write it. This is disabled because the page is locked. I'm going to open it. Just yeah. So now I'm going to write the text A B C D. Okay, right. So the write is successful. Now even though the pages is locked, I'm still able to write it. What I've not done is, I have not reactivated the tag. So this shows what the paragraph says. The write is the locks are effective only in the next request. So I'm going to bring this, reset this tag again, activate, read. So let's go to page number 36. It's written. Let us try to write this time. So I'm going to click on page 37. Because it's locked, it is disabled. Let's go to the safe mode. You have to just move the position of the row. Let us try to write this time, say 203, sorry, 203T. So I'm going to, before that, let's check out all these previous commands. So I'm going to write. So here the write failed. Let us see what has happened. So as usual, we are sending the write command, but we received 9004. The 00 is a negative acknowledgement. So this is where the write failed. It is very obvious because the page is locked and the locks are in effect. So you know that any of these MIFI tags, or probably in any tag, when you try to do something like this, trying to write to a protected page, they will automatically reset. So the only way to come out is to reactivate and read again. So let's try again. If you just try to write, so write failed, try to read. Here it says, this is the response I got. So whenever you see the response, you have to reactivate the tag and read. Okay, so we just saw that writing to a locked page, okay, that will lead to an error. So likewise, next is the block locking. So I mentioned this in my ultralight videos. The block locking bit locks the bits here. So for example, BL2839 means if this is ticked, all these bits they become read only. You can't change this thing. Let us do that. So assume that I don't want anybody to lock the page. This is already locked, so just go to the safe mode. So this is already locked and you cannot unlock it. So I'm going to tick this. So by doing that and write, so I have basically prevented user from locking this or changing this bit. Now how do we know that? So let us try to change this, the lock, and see whether what I said is true. So I'm going to restart this tag. So here let us go to this safe mode. I'm trying to change, thinking that I can modify this log bits. Let us try to undo. Let us try to write this. So write. The write looks like successful. However, when you go and read the data again, I've got a tiny little feature here. Any point of time you can go to the page and click on the R link. This reads the data from the tag and populates or refreshes the screen. So click on this, know that you got back the original value. So this shows the lock bits. Once they are set, you cannot undo them. So likewise, I can also, let's go and modify. I'm going to lock, just lock because I'm going to destroy this tag. I'm going to lock this and further this, right? So this is all locked. Okay, so to bring this lock into effect, you have to again reset the tag, and so many pages are locked. Page 20, let us try to write. So I'm going to go to the safe mode and try to write here, write number 25,000. Right, the write failed because this is a protected page, and the only way to come out of this is to activate and read again. So that is how the lock, so dynamic lock works. The next thing is I'm going to just one more feature which I would like to cover, which we have seen this in detail, is this use compatibility write. And you know that this write operation sends 16 bytes even though only 4 bytes are returned. Let's try to, I'm going to change the value of this to say A, B, C, D. This time I'm going to use the compatible write. Let's take out all these commands. Now write. So if you can see here, the compatible write means we have to send all the 16 bytes. However, only the first 4 bytes are returned. So the next thing I would like to cover is the counter. Next I'm going to show you about the counters. So as the name says, counters are meant for counting, and the counting is always in one direction. So this is a 16-bit counter. You can start from 0 when for a brand new tag it will be 0, and you can go up to the maximum for 16-bit, probably it's 32,000, I think 657 or something like that. Okay, so this is always increments, you cannot decrement. In other words, if the value of the counter is 1000, next time you can make this number bigger than 1000, you cannot reduce it. So there are so many applications of this counter. So let us see how the counters are used. So I'm going to place the same tag, activate. Now the counter in this tag is present in page number 41, and if you see the documentation, it is the first 2 bytes or 16 bits. The documentation says the very first time you can use a normal write operation to set the counter. However, I do have a small section here. This is for a counter, and this basically to add a number to the counter and goes only from 0 to 15. This is exactly what the documentation says. Once the counter is initialized by means of a write operation, after that you cannot write or you cannot add more than 16 at a time. So let's try to do that now. So I'm going to initialize this counter. Keep in mind the initializing counter is done by a normal write operation. So I'm going to initialize this counter with 1000, and here what you can see is, so this is the lower byte and this is the higher byte. So I'm going to write. So you can see here lower byte and higher byte, and also I have also shown the value of the counter in decimals. It is 1000 here. And once this is done, you cannot increase this by more than 16. So there is no separate command for counter operations. It is just a normal write operation. So I'm just going to clear, and just to make sure that I'm just going to restart this tag again. So if you see the counter, I'm going to increment it by 3. So let's clear the screen and say, to increment a counter you just have to write, use a write command. So say add. The counter has gone up by 3, and let us see what has happened in the command side. So we still have to send the 4 bytes. However, I'm sending only the value for the just the first byte, the remaining bytes are zeros. And after that you got a positive acknowledgement, and when I'm trying to read the value of this counter again, everything, and after reading, I'm just populating the value of the counter. So it's very simple in a counter. So only thing you cannot update, just assume that I try to write here, say just try to increase this by say 150. Now what do you think will happen here? 150. Okay, so let us take this the binary value of 96. So this will be 10010110. So we are trying to write this byte, and what you're going to see eventually is only the lower 4 bits will get added to the counter. So let us try to do that. So it is 100,003, say write. So this has become 1009. So that's what the documentation says. You cannot write more than 16, and the maximum value of the counter is all FFs. So once the counter reaches all FF, I cannot do that now. To do this, you'll end up writing thousands of write statements here, which I don't want to waste time. So that is how the counter is. Now you can add 0, say add, nothing has happened, so adding 0 is allowed. However, keep in mind you can't add more than 16, and there are locking bits for counter also. Say here you got BL, assume that I don't want anybody to lock the counter. I can set this bit and write, or let us try to lock the counter. So when you lock the counter, this is just like locking a page, so nobody can modify. So I'm going to write the lock bits. The lock bits will come into effect only after next restart. Let us try to play with that before try to write your locked byte. So I'm going to unlock. So I'm going to write 5 more, add. Look at that, I'm still able to write, so the lock is not in effect. So let's try to restart this tag again, activate. So here, so this is my software shows it is locked, so you don't see the add button. I'm going to unlock that, try to add 3. So this is an error. So once there's an error, you cannot read any further. The only way to do is reactivate and reread. Okay, and that's all about the counter. So before I finish, I would like to show you something in eBay. These are some of the things I sell as a learning kit, and I've just made available this software. And if you go to eBay, and you can, so this is I've got few spare M24 LR discovery boards. So I'm just putting this on eBay, and I'm also giving away so many tags with this kit. So probably if you get a chance, if you see them, you can buy, because I got just 2 available here. And if you already have that board, you can just go with a pure software. So this is the software which I have been using for these videos. And if you already have this kit, you want to learn more, and you can just buy this software also. Thanks for watching, guys. Please subscribe. That CR95HF, it's so interesting piece of hardware, and I'll be doing more videos. Probably by next video will be on the MiFair Ultralight EV1, and followed by Ultralight C, followed by NTAG212, 213, Desfire. I've just added these 3 today. I got few Topaz tag as well, so I'm going to cover on that. And I also one of the reader asked me if I can do a video on NXP iCode, which I just purchased the tags, but I also don't know. Probably after a few weeks, we'll have a nice video on this as well. And the most interesting bit, I'm looking forward to demonstrate this board. So this is the CR95HF board, also called BM019, and I'm going to spend a few videos on this as well. Okay, thank you.